Now that we've set up this nice whitewater effect for this close-up shot, let's go ahead and set up this whitewater for the wide shot as well. And thankfully, we can reuse most of this setup as it is. So let's go up to the object context and then go to this whitewater close-up here. And let's copy that and paste in a copy. Then I'll rename this to whitewater wide. And diving inside this copy of the setup, there are a number of object merges that we need to point to the wide shot of the river instead of the close-up. So a couple of these will be the collision geometry. For these object merges, we can just remove the underscore close-up from that object path there. Because things are set up the same way in that river simulation, this is linking to the entire wide shot collision geometry just by removing that underscore close-up portion there. And we can do the same thing for the collision volume. Select that object merge, remove underscore close-up, and we can do that for the river area. Select that object merge, remove underscore close-up, and of course we need to link up the simulation as well. However, this out-river sim null wasn't in the original version of the river setup. We added this null when we were working on the close-up whitewater. So let's add this null to the river setup as well. So I'll pin my viewport here, go back to the river setup, and actually it looks like we do have a null here already. It's just called something different. It's called out cached sim. So back to the whitewater wide shot, we can change the simulation path. So that points to river/out cached sim. So now we have the entire simulation being imported for the wide version of that river as well. And with those various imports updated, we get our bounding box automatically as well. Although we do need to change a few other things in here. Let's go through the Riverside Points setup. Let's see how that looks when it's unpacked and clipped. And it was pretty slow to clip that heavy geometry, but this all looks pretty good. I'm happy with that as it is. And moving on in this Riverside Points setup, we don't need to do this camera-based grouping, since our wide shot is including this entire region in its camera view. So we can just bypass or delete this portion. We are going to continue using this next group SOP, which is grouping the points that lie within that collision volume SDF. This is still very useful for that wide shot. This extra custom grouping based on the sphere doesn't really make much difference either way. It's up to you if you want to include this or delete it. In this case, I'm just going to remove that. So this has simplified our Riverside Points setup quite a bit. It's a bit more condensed than it was previously. And after blasting away those selected regions, this all looks quite good. There are a few spots here that are being missed by that grouping setup. It doesn't really matter because we're not going to get any emission here because it's not touched by the simulation surface. So it doesn't matter too much if we have a few bits on the outside here. So I think this is clean enough for our needs. And on this scatter SOP here, because the camera isn't nearly as close to the river as it was in the other shot, we don't need to use quite as dense of a point cloud here. So I'm going to reduce the density. You can change these values, but sometimes when I want to keep some relationship to the previous value, I'll just use multipliers instead. So in this case, if I want this to be 30% of the points that we had before, I'll say 0.3 times 8,000. And let's see what that scatter looks like. This is giving us close to 2 million points, and it looks like a reasonable resolution for this wide shot. So with this all set up, let's make a new cache for these Riverside Points. I'll rename this cache to wide instead of water close-up. Let's display that and save this to disk. And we can move on to make sure that the selection based on contact with the water surface is all working properly. We have that water surface being imported here, so that looks all good. And then we can check that water contact group. This looks fine as well. And for the noise pattern on this, I'm going to keep this all the same as it was for the close-up shot. This patchy pattern should work well for the wide shot also. And moving on to the whitewater source, we no longer need to use this camera-based masking because the entire river is now in view. So instead of this camera mask, let's use a mask based on the entire river area. So I'm going to delete this camera here, delete the camera mask null, but we can still use the same VDB from polygons, and then build the emission region based on this river area of interest. So I'll take a copy of this object merge, paste it down here, and let's display that. And let's delete the rocks and the extended sides of this river. So on this blast, let's select the extrude side group, and then anything that has rock in the name. So in addition to extrude side, I'll say at name equals rock star. So this is just isolating the riverbed area, and we can use an extrude volume with an upwards extrusion to define the valid emission area. So drop in that extrude volume and display that. Let's set this to smooth wire shaded to see that a bit more easily. And by default, this is extruding downward. So let's extrude this upwards instead. It looks like a value of 2 isn't quite enough. I'll set that depth to 7. And this looks like it should work just fine. Now let's connect that to the VDB from polygons. So this is creating a fog volume for the valid emission region. And that's already connected to the whitewater source. And on the Volumes tab, this is enabled with this checkbox under Mask Name, and it's looking for this density volume to find the valid emission region. And for the voxel size resolution on this whitewater source, because the camera is much farther away now, I'm going to try just doubling this voxel size. And now let's display this whitewater source. And it looks like we're getting some reasonable results right away. And of course, you may need to go back and forth between tweaking your source, seeing how that responds in the simulation, seeing how that looks in the render, and then adjusting your source accordingly once again. But for my wide shot, I wound up disabling the acceleration emission entirely. And then for the vorticity, I turned down the vorticity range quite a bit. And I also expanded it by adding 60 instead of 40. So let's turn the vorticity minimum down to 45. So you can see we're getting more vorticity-based points being sourced now. And I'll increase that vorticity range to 60, which isn't changing things too much, but this seemed to work out fairly well for my sim. Under the extra sources, you can increase the particle scale if you'd like, so that those emission areas based on those input points are a bit larger. Let's see what it looks like if we multiply that by 3. And that could be a bit too much. Let's turn that down a little bit and multiply that particle scale by 2 instead, and then see how this looks in our simulation. And finally, on this emission tab here, the speed range may be quite a bit different between different simulations, even if the setup they're based on is essentially the same. So when using the setup on a different shot, you may need to adjust the speed range accordingly. For my wide shot, I just used a speed range from 1 to 2. So I'm pretty happy with how this source is looking so far. Of course, we need to see how it looks in the sim, which will be running soon enough. And we don't need to update very much in the simulation. So if we dive inside this DOPNet and go to the whitewater solver, we will need to reduce the resolution of this whitewater. For the wide shot, we don't need nearly as much resolution as we do for the close-up. So by increasing the whitewater scale, that increases the particle separation, which effectively makes it a lower quality, lower resolution sim. So I'll put a multiplier on here of 2.5 times our old value, which gives us a whitewater scale of 0.0375. So we'll try that. And then jumping out of the DOPNet, let's rewind the simulation and display the DOP import and step forward a frame. So we are getting some whitewater particles out of the sim, so everything is working, at least from a technical standpoint. So we can go ahead and run some caches of this wide shot whitewater. And as I've mentioned in some previous videos, when you copy a setup, you have to be very careful not to overwrite caches for the shot that you copied it from. So for our simulation cache here, let's change this path. Instead of close-up, let's write this to wide-whitewater version 1. and change that file name as well to Wide Whitewater. And we're basing our whitewater sim on the simulation of the river without the time offset applied. So we can cache out the same time range as the river sim and then make sure that our time shift afterwards matches what we used for the river. So I'll set this to cache from frame 1 to 300. And now let's save out this simulation. Now this whitewater sim is all finished caching. This took around 35 minutes on my machine while I was doing some other things on my machine at the same time, and it's only giving us 200,000 points, so we certainly could push this quite a bit higher resolution. We could perhaps push this 2 or 4 times higher resolution than it is right now, but of course we can flipbook this and render it to see if that resolution is really necessary or if we don't get big gains out of it at the wider camera view. So let's do a flipbook of this to see how it's looking. And when we copied over the entire setup, that included this reference to the meshed version of the river. However, this meshed with color null is a null that we added while working on the close-up whitewater shot. So I'll just copy that name, go back to the river setup, and then go to the meshed river down here. This is after we've added the color for visualization. And let's add in a null here. Connect that to the colored mesh. And I'll give this the same name as we did for the close-up. I'll call this out meshed with color. Now if we go back to the whitewater wide setup, we can update this object merge to, instead of pointing to river close-up, we'll point this to the standard river out meshed with color. And let's template view this. And if we look back at the river setup, you can see that this meshed version of the river is happening after the time shift. So we've time shifted the river simulation by 40 frames so that it looks nice at the very start frame of our shot. And we're going to directly reference this time offset in our whitewater setup so that if you change the time offset on the river here, it's automatically updated for the whitewater as well. So those always match. So on the time shift here, let's right-click this offset parameter and copy that. Then go back to our whitewater setup and drop in a time shift here. Let's drop this just before the sim scale inversion. Select our time offset preset and paste that relative reference into the offset parameter. So this is automatically linked to the offset that we choose in the river setup. So now if we display this visualize null, now this is giving us the whitewater with the correct time offset, and it's nicely matching with our actual flip mesh for that wide river. And let's set our viewport to show all objects so we can see this in context with the environment. We do need to do a bit of cleanup on these whitewater particles to delete some of these particles that are sticking off the edge, which might be a problem at the other end as well. Yeah, we can do this cleanup post-simulation. That's totally fine. You could add a pop kill inside your setup to kill some particles in specific volumes. Or you can just handle this post-simulation. That's totally up to you. And conveniently, we already have some volumes in our river setup that we can use to chop off some of these edges of the sim. If you remember from our flip setup, we set up some boundary sink volumes on the ends of the river, and those should work nicely to kill these particles. So let's drop in an object merge, and I'll point this to object/river/boundary sink, and let's display that. And we're not seeing this in our current view here because those boundary sinks are set up at the simulation scale. So let's hide other objects for a moment. So we can either apply the trimming with this boundary sink at the simulation scale, or we could scale up these boundary volumes in order to apply that extra bit of cleanup at the actual rendering scale. Either way is totally fine. So let's display the file cache output directly. Turn off my river template view for the moment. Make some space for that cleanup there. And let's drop in a group sup. I'll call this cleanup. Group type will be points. Turn off the base group, turn on bounding regions. And when we're using an SDF, we can either use a bounding object or a bounding volume. Either is totally fine. So let's connect our boundary sync here. And on the group for this cleanup, let's select the bounding object and display that group. You can see this is selecting those particles beyond the edges of our simulation here. So we can just drop in a blast stop, select that cleanup group, display that. And because we don't need this cleanup group anymore, we can turn on delete unused groups. It's always nice to keep things as clean as possible. And with that extra bit of cleanup applied, let's once again display our whitewater points on this visualize null. Let's bring back the template display on the river. Let's go back to our rendering camera for the wide shot, and then set the viewport to show all objects. Now this is looking very promising in context with everything else. It does look like the particles are still extending a bit beyond the edge of the environment though, so we could adjust the cleanup a bit there. So if we go back to the group for that cleanup, because our input is a VDB SDF, we can change this group bounding type to use a bounding volume instead, and this allows us to use the ISO surface as an offset. So if we increase this ISO surface parameter, then we can extend that cleanup a bit more. However, we do reach the limits of the data stored in this VDB. So you can see once we start to push this ISO surface value too far, then that SDF is just no longer storing any distances beyond a certain range. So it looks like we can't push this ISO surface value quite far enough. So I'll just set this back to its default value, and instead of using that ISO surface parameter, let's use a VDB reshape SDF. Then we can use the dilate option on this to expand that VDB. So just dropping that on our boundary sync with its default settings is doing a little bit more cleanup than before. And as we turn up the offset on this, it's doing more and more cleanup. So it looks like 10 does the job pretty well. Let's display this before we apply the alpha value so we can see those points a little bit better. I'm going to go with the value of 10 here, since that cleanup is looking pretty good. And we can check the backside as well, even though that's not very visible from our wide camera. So that improved cleanup there is certainly helping. So now with that fixed, let's go back to the wide camera once again. And let's put our display flag back on this visualize null here, because the whitewater particles do look better with that lower alpha value included. And now let's run a flipbook of this entire shot. Now after flipbooking our whitewater sim, this is all looking very good, so we can go ahead and start rendering this. Of course, the render setup for the wide shot is no different than it was for the close-up shot. So let's go up to the object context and go up to our render objects, and we can make a copy of the render object for that whitewater. So we have objects for the whitewater close-up, and the second one will just be whitewater wide. This already has the material applied, it already has motion blur enabled from velocity, and it's set to be rendered as particles. So let's dive inside this render object. And instead of whitewater close-up, let's point this to whitewater wide. So that's bringing in all of those particles correctly. And we can go to the out context and to our wide ENV render. And under force objects, let's add this render whitewater wide. I'll disable creatures just for now. And I'll disable the creature lighting for now as well. Let's take a look at what our sampling is set to. I'll turn off automatic sampling for this test render. I'll leave it on 4 and 32 for the max samples. And I'm going to leave global illumination on for now. Now let's go to the Redshift render view. And under the Houdini menu, select ROP. Let's go to wide ENV. And for the wide shot test render, I'm going to render this at full resolution. So instead of fixed scaling, I'll select original size. The river and whitewater is going to be much smaller, of course, in the wide shot, so that extra bit of resolution will help to get a better look at it before we commit to rendering a full sequence for the shot. So now let's render that IPR for the wide ENV. Now it is a bit hard to see the whitewater in this test render here, so let's try to exaggerate this a bit to make sure that it's working from a technical standpoint. And to make the test render a bit faster, I'm going to remove the destruction here. So under Objects and Force Objects, I'll remove the Render ENV and add in the Render ENV No Fracture. For the final renders, we'll of course want to bring back that Render ENV to include the destruction, but not including that destruction now will speed up our tests. And then we can also try exaggerating the size of all the whitewater particles. So if we go back to the object context, on the render object for that whitewater, under the Redshift and Particles tab, there is this global scale multiplier, which will increase the size of all our particles. So let's try cranking this up 10 times, just to see if we can get a better read on these particles here. And with all of those updates to those objects, let's do a full refresh on this IPR. Now after cranking up that global scale multiplier, our whitewater particles are much more visible, and it's totally fine to use this parameter to dial in the look of your whitewater. You're not cheating or doing anything wrong to adjust things this way. And this is a great example of a case where adjusting that global scale multiplier could absolutely make sense. It was quite hard to see the whitewater before turning the scale multiplier up, so we can play around with this a bit more and find a sweet spot for that scale size. We can also enable the render region so that we don't have to sample this entire image as we're dialing in that whitewater scale. And because that's a bit overkill to use 10, let's try turning this down to 3. Now a value of 3 seems fairly reasonable. It is hard to clearly see this whitewater, but oftentimes subtle effects are really the best kind. If we really go over the top and try to make this whitewater super visible, then it could start to look fairly fake and forced. So some subtlety in this whitewater could look quite nice. So feel free to play around with these things and render out the sequence to see how it looks in motion. Of course, you can go back to the shader, you can make a separate copy of the shader just for the wide shot, perhaps play around with the brightness of the color. That could be another way to potentially bring out the whitewater a bit more without adjusting the size. And then finally, after dialing in a look that you're happy with, you should wind up with a result something like this.